Welcome to DELD course. In this video, we will study about the digital IC characteristics. There are various characteristics of digital ICs which are used to compare their performance. And these characteristics are speed of operation, power dissipation, figure of merit, fan out, different current and voltage parameters, noise immunity, and operating temperature. Now we'll see the speed of operation. Speed of operation is specified in terms of propagation delay time. To understand this, we will take the input and output waveform of a NOT gate. This is the input waveform of a NOT gate given to the NOT gate, and this is the output. When we are giving the input, immediately we are not getting the output. Some time delay will be there to get the response. There are two time delays, the TPHL and TPLH. TPHL is the propagation time delay when output is changing from high state to low state. And another is TPLH. It is the propagation time delay when output is changing from low state to high state. So total time period T, time delay is the average of these two time delays, TPHL and TPLH. So TP, propagation delay time, is equal to TPHL plus TPLH by divided by 2, and it is measured in nanosecond. In other words, the propagation delay time is the time interval between the application of the input voltage and measure occurrence of the resultant output voltage, and it is measured between 50% of voltage levels of input and output waveforms. Next, another is the power dissipation. Next parameter is a power dissipation. For this power dissipation is the product of VCC and ICC. That means it is the power product of supply voltage and current drawn from that supply. Now ICC, current drawn from the supply, are of two types. That is ICC we are taking as average, and it is nothing but the average of ICC 0 and ICC 1. This means ICC 0 is the value of current ICC drawn from the VCC supply when output is low. ICC 1 is the value of ICC drawn from the supply VCC when output is high, and average of this is taken, and then propagation delay is the product of supply voltage and ICC average. Next parameter is the figure of merit, FOM, figure of merit. Figure of merit is the product of propagation delay time and power. Figure of merit, propagation delay time and power. Propagation delay time is measured in nanosecond and power is in milliwatt. So this is specified in picojoules. Nanosecond into milliwatt is nothing but a picojoules. So figure of merit is measured in picojoules, and the figure of merit of IC is defined as the product of speed and power, but the speed is specified in terms of the propagation delay time. So it is figure of merit is equal to propagation delay time and power dissipation. Next parameter is fan out. For this fan out, the definition is this: it's a maximum number of similar gates which can be driven by a gate. That means, for example, if you take a NAND gate, that means output of this NAND gate, how many number of gates gates, same gates, NAND gates, it can drive. That means output of this NAND gate capable to how much number of maximum number of NAND gates it can drive. That number is called as a fan out. The next parameter is voltage and current parameters. For that we are taking the two different levels at the input of the gates and output of the gates. For the input of the gate, logic 0, logic 1, this is VIL, VIH, where VIL is a low level input voltage, VIH high level input voltage. This is logic 0, this is logic 1. VOL is the low level output voltage, VOH is high level output voltage. From this figure we will get the idea. VIL, what is the definition of VIL? VIL is the maximum input voltage which can be recognized by the gate as a logic 0. Similarly, VIH is the minimum input voltage which is recognized by the gate as a logic 1. The same way, if output side, output voltage VOL is the low level output voltage. VOH is the high level output voltage. VOL can be defined in this way. It is a maximum voltage available at the output corresponding to logic 0. VOH is the minimum voltage available at the output corresponding to logic 1. Now next parameter is a noise margin. For that we will consider this figure. We are mentioning VOL, VIL, VIH and VOH. Now this del 0 indicates this is a noise margin at logic 0 state noise margin. Del 1 logic 1 state noise margin. Logic 0 noise margin is equal to VIL minus VOL, and logic 1 noise margin is equal to VOH minus VIH. Now we can define the noise margin. Actually, due to the electric and magnetic fields, some unwanted voltage is developed, and that is called as a noise. That means due to the electric and magnetic field, unwanted voltage is induced, and that is referred as a noise voltage. And due to this voltage as the input to the logic circuit, due to this unwanted signal generation, the voltage at the input to the logic circuit will drop below VIH and rise above VIL and may produce undesirable operation. The circuit ability to tolerate noise signals is referred as a noise immunity. And a quantitative measure of noise immunity is called as a noise margin. Last parameter is operating temperature. There are scale 0 degree centigrade to plus 70 degree centigrade temperature for consumer and industrial applications, and another range is this minus 55 degree centigrade to plus 125 degree centigrade for military purposes. Thank you.